Hi guys, so let's talk about section 9.1. So chapter 9 is actually about trigonometry, and you'll see that I spent quite a bit of time putting some resources up for you on Schoologizzle. So I think, let me show that to you. Where is that? Here, okay. So, first of all, I think if you go to Wikipedia or maybe some other sources too, you'll see that Hipparchus is called the father of trigonometry because he's one of the Greek astronomers that are most credited with basically practicing trigonometry. And so, any case, this, just so that you know, this is not a new thing. This guy lived from 190 to 120 BC and practiced mathematics and astronomy and trigonometry back then. So we're learning something that's not very new. It was discovered a long time ago. Okay, and also very important that you realize that again, all of mathematics is to help us, is basically a gift from God to help us solve problems. So I have a few examples. If you go into Schoology and you look right at the beginning, I have some links which I'm going to show you two more of them. I've already shown you this one, but just two applications of right triangle trigonometry, two simple ones, and one here is basically figuring out the slope or grade of a hill, and this is in the context of a job or occupation called land surveying. Okay, so in the occupation of land surveying, people want to find out how steep is a piece of land so that they can report that to people who build roads or all kinds of reasons why you want to know how steep a piece of land is. And so you can look at this and quickly see it's just a right triangle. And so right triangle trigonometry will enable you to do something like this, which is not very easy to do, especially if the distance from A to B is a very long distance. This is not actually easy to do, but right triangle trigonometry will allow you to do that. Okay, and then the other one was just another quick little application that I thought of showing you was land surveying. I mean, not land surveying, sorry, was to figure out the cloud ceiling. So this is just another, you can look at this picture here and see a nice little right triangle, just like this, okay? And this basically, what they do here is a weather office would try and figure out if it's safe for small planes to fly, and they would want to figure out what's the cloud ceiling, how high is the clouds from the ground, how many feet, and is it then safe for little small planes to fly. And so they'll shine a light up at the clouds, and where it touches the clouds, they'll measure the angle of elevation, which we'll talk a little bit about later about in our lesson. And then you can just create a simple right triangle and figure out the height of the clouds. Okay, so not easy to do. You don't want to send a plane up there. You want to do, I mean, what else would you do? It'd be kind of troublesome to do. So, any case, that's another application there. So, you know, on your note sheet, you can make a note of land surveying and maybe finding the cloud ceiling in aviation. Okay. And Hipparchus, father of trigonometry. All right. Let's jump in and actually just do some math. Okay. So right triangles. Everybody's okay with right triangles, I'm assuming. You know that we call the side opposite the right angle the hypotenuse, and then if this is my angle theta, we call the side opposite this angle opposite, and this side is called adjacent. Okay, so this changes. So if I'm looking at this triangle from the perspective of this angle, then we call this side the opposite side to that angle, and this is the adjacent side to that angle, and this side opposite the right angle is always hypotenuse. Okay, now you can't change that and then say, wait, what if this is angle, I don't know, beta, and then I'm looking at the triangle from the perspective of angle beta, then this side would actually become the opposite side, and this side would become the adjacent side. Okay, hypotenuse stays hypotenuse. So just perspectives on looking at a triangle. For us, usually we're going to call an angle theta and then work from there. And if you look at all these trigonometric ratios, that's what you get. So sine of theta is the length of the opposite side divided by the length of the adjacent side, divided by the length of the hypotenuse. Okay, and you get some number. And so this is, please, you don't have to think that the trigonometric ratios are some mysterious thing. They're just literally a ratio of two sides to each other. Okay, and they actually work for any kind of triangle that has this angle and is a right triangle. If let's say, I'll do a quick example. If you have, let's say, an angle of 32 degrees here, and this side length is 5, okay, and you say, what is the sine of 32 degrees? You'll find out that the length of this side is, I don't know. Well, let's figure it out. Let's say it's x. You'll get sine of 32 is, according to this, opposite over hypotenuse. So it's x over 5. So we'll see. Let me go here and see. What is that actually? So 5 times sine of 32. Ooh, that's not going to work because my calculator is not in the right mode. And I want to show you how to do that later. So let me do it on the side here. 5 times sine of 32. And so you get something like x is approximately 2.65, something like this, okay? X is approximately 2.65. And so actually what that means is the sine of 32 degrees is 2.65 over 5. So the sine of 32 degrees is approximately, and if you do that, I think you get 0.53. Okay? And so if I go to another triangle that looks fairly different, it's still a right triangle, still has this angle, 32 degrees, which makes it a similar triangle with this one now, but it's a bigger triangle. Let's say this side length is 10. Then by similarity, I know a few things now, okay? I actually know that the sine of 32 degrees for this big triangle must also be approximately 0.53 because they're similar triangles, okay? And how that works is if this side is twice as long as that side, then this side must be twice as long as the other side. So I actually already know that this side length here must be 2 times 2.65, okay, and that's about 5.3. All right, and if you look at that carefully, if I say sine of 32 degrees for this triangle would then be 10 over 5.3, which is about 0.53. So you'll see that that's the common thing here. All of these ratios are just ratios of sides for similar triangles. Okay, for similar triangles. So that's all it is. It's not some mysterious thing. I think sometimes people think, where does sine theta? What does that even mean? And it's not that mysterious. Okay. All right. So let's move on. And there's just one thing I have to show you here. There's a little acronym. Okay. So TOA that you can remember to memorize all of these and how they work. Okay, so all of those trigonometric ratios, and what it means is sine of theta is opposite over hypotenuse, and then this one means cosine of theta is adjacent over hypotenuse, and this one means tangent of theta is opposite over adjacent. Okay, and once you have those memorized, then the corresponding ones, so please, this is important to know that these two are corresponding trigonometric ratios, and so are the other two. Okay, so cosecant of theta is just the reciprocal of sine theta. secant theta is the reciprocal of cosine theta, and cotangent theta is the reciprocal of tangent theta. Okay, so those go together. So if you know this one, then you really know cosecant. And if you know cosine, then you know secant. And if you know tangent, you know cotangent. Okay? And then also there's another very important little identity here, that if cosecant is the reciprocal of sine, then this should also be true, which makes logical sense. Okay? So if they're the reciprocals here, then this is also a relationship that's true, and that makes a lot of sense. Reciprocal means reciprocal. Okay? All right, so hopefully that's something you remember. And so I think this is actually quite important. They have at least here for you a visualization of how you say this Greek letter. It's the Greek letter T, okay, theta. So we say theta in America, or, you know, I think in Greece they don't say theta, they say theta or something like that. It's actually pronounced quite differently. But in any case, that's how we're going to say it. All right. So let's do example 1. It says evaluate the 6 trigonometric functions of the angle theta. So in other words, what that means is of the angle theta means I'm looking at the triangle from this angle, and then I'm going to evaluate the 6 trigonometric functions. So I'm going to look here and say this is my opposite side, and that would mean this is my adjacent side, and that would mean my hypotenuse is always here. Okay, so the 6 trigonometric functions are sine of theta. I don't know what theta is, but I'm just doing what they tell me. Sine of theta is opposite over hypotenuse. Again, you can write this to help yourself. At some point, you have to let go of this, but you know, you should just know it. But for now, sine is opposite over hypotenuse. Okay, so I can just do, that's 12 over, oh, I don't know the hypotenuse. So what do I have to do? I have to go and actually find the hypotenuse. So hypotenuse is associated with letter C normally. So I'll just do c squared, and this is from Pythagorean theorem. C squared equals 5 squared plus 12 squared. That's c squared equals 25 plus 144. That's c squared is 169, which means I can't write that, which means c is 13. Okay, so the hypotenuse is 13. This is a famous Pythagorean triple. 5, 12, 13 is a famous Pythagorean triple, just like another one which is 3, 4, and 5. Okay, 2 legs in the hypotenuse, 2 legs in the hypotenuse of a right triangle. Any case, so now that I have the hypotenuse, I can just fill this in, 13. Okay, and then other question was, let me separate this out a little bit, the 6, so 6, all 6. So cosine of theta is adjacent over hypotenuse, and I really should write it like that so it matches our little thing up here. Adjacent over hypotenuse, and then I just say adjacent is 5 and hypotenuse is 13, and then tangent of theta is opposite over adjacent, and so opposite is 12 over adjacent, which is 5. Okay, and that's about that. And then the question was all 6 trigonometric identities. So let me do the corresponding one for sine theta is cosecant theta, and that is the reciprocal of this, so it's hypotenuse over opposite, and that is 13 over 12. And then the corresponding one for cosine is secant theta, and that is the reciprocal of this, which is hypotenuse over adjacent, and that is 13 over 5. And then this one is the cotangent of theta, which is the reciprocal of that, which is adjacent over opposite, which is 5 over 12. Okay? And again, this is really not that important. This is just like little baby step on the way to solving problems, okay? Unfortunately, if you don't know this stuff, you can't do really any trigonometry. But so it's a simple thing, but you got to know how to do it, all right? Any case, and then example 2 says find the value of a trigonometric function given the value of one of the 6 trigonometric functions, okay? So here's the setup. In a right triangle, okay, so there's a right triangle. There's a right triangle. Theta is an acute angle, okay? There it is, there's theta. And cosine of that angle is 7/10. So if I look here, from this perspective of this angle, remember cosine of theta is adjacent over hypotenuse. Okay, it's the ka in my SOHCAHTOA. So that means that the adjacent side is 7 and the hypotenuse is 10. So from this angle's perspective, here's the adjacent side. So that adjacent side would be 7 and then the hypotenuse is 10. Okay? This is great. I just basically used that information to draw a triangle. And then it said, what is sine of theta? What is sine of theta? So, well, sine theta is opposite over hypotenuse, okay? And then I say, well, what is it? Well, from the perspective of theta, the opposite angle, the opposite side is this. So the opposite side is this, but we don't know what it is. So now what I have to do is do Pythagorean theorem again, just to find that little, the missing side, okay? And so all you do is go over here and say 10 squared equals the opposite side squared plus 7 squared. And you can do other letters or whatever you want to do, but I'm just going to do that, okay? And then you get 100 equals the opposite side squared plus 49. And if you subtract that, you get 51 is the opposite side squared. So that would mean that root 51 is the opposite side's length. So we can fill this in. This is root 51. So sine of theta is opposite, which is root 51, over hypotenuse, which is 10. Okay? All right, so that's how you answer that type of a question. I am going to not do this with you. I think this is worth doing as an activity. Like this is an inquiry-based little activity where you sit and really think about what's going on with these triangles. Probably the easiest thing to do would just be to go through and find all the missing information and then look at them for a while and see if you can see anything. So I'm going to give you the missing information. Okay. If you want to do this, go do it yourself. Pause the video and go do some inquiry thinking about this. Think about it really hard. It is valuable to know some of this stuff, but I'm going to just quickly fill in the missing information. Okay. So there's the missing information there. And then this one would be, I think it's 2 root 3 goes there. Okay. So the question here is, we're looking at all of these. That's great. We see some answers. That's great. I did an example with you earlier, which you can see that some of these things have some strange answers. They're not really exact. That would be an approximation because root 51 is irrational. So here we have 2 triangles that occur a lot, and we use them a lot. They're used for construction, architecture, all kinds of things. These angles are very, very important in building homes and building structures, and if you're an architect, technical drawings to make those structures and all those kind of things. Woodworking, any kind of thing you do, you need if you build anything, you need to know something about these ratios. Okay, they're also very good because we get exact answers for this. So root 3 is irrational, but I know the exact answer. Okay, I can say, I know that this side is 7 root 3, so that's an exact answer. That's exact. Okay, and so for other triangles, we get sides that we don't really know what the relationship is. It's some strange, weird, approximate number or something. And so for these 2 triangles, because they're used a lot, we studied them and we have all kinds of information about them. Now, if you look at this one, I just completed the information for this one. Okay, you can sit there and stare at it for a while and figure out relationships. All right. If you see that this, you say, how do I get from 7 to 14? Well, that's multiplied by 2. How do I get from 7 to 7 root 3? Well, that's multiplied by root 3. Is it the same here? Yes. Yes. Wow, amazing. Okay. Now, how do I go from here to here? That's not so easy. All right. That's more tricky, and I don't think that's necessary. Okay, but or how do I go backwards from 7 root 3 to 7? What do? I just divide by root 3. And you can see that the pattern holds here. Multiply by 2, multiply by root 3, and vice versa. Okay? So, those are important to know. They're also important to know that they make your problem solving much, much quicker if you know them. Alright? So we're just building up some basic tools here. This one, same thing. I will just fill in the missing information. And then what you can do, and this is a mistake, obviously, this should be 7. What you can do is also look at this and see the relationship between them. So, I mean, the two legs are always the same length, but how do I find out the hypotenuse length if I know a leg's length? Well, it looks like I just multiply by root 2, and that would be correct. And if I know the hypotenuse length, how do I find the leg length? Well, I just divide by root 2, and that would be correct too. So, this was supposed to be a little inquiry activity that we do in class, but of course we're not in class. So there's that. I would think it would be useful for you to write up a little summary of that. If you don't want to, just go look at the completed note sheet and you can see the summary there. Okay. Which brings us to these two special triangles. Okay, so you can see all of these are similar triangles. Interesting, again, similar triangles. Those three are similar, these three are similar. Okay, they are angle similar. All right, angle similar, or angle similar, different, however you want to go about that. Okay, those are all similar triangles, and so it means that we can actually reduce them to something that has they all have the same sine of 30. It's all the same. Okay, or sine of 60, it's all the same answer actually. It's different sides but the same ratio when you do the math. And so here it can basically be reduced to this. Okay, it can basically be reduced to this. Now I don't recommend that you memorize this. If you want to, knock yourself out, but I have never memorized that. I just actually have this in my head, and then I go from there to find out any information I need. Okay. And so basically what I'm saying to you is, please, and I wrote a message for you here, you must be able to draw these two guys from memory. You must know them. They're very, very important in all kinds of applications in real life, and just for you to be able to do trigonometry, and therefore to be able to do calculus and pre-calculus and all that kind of stuff. Eventually, your reliance on this goes away, but for most of what we're going to do this year with trigonometry is very important. So, how does this work? It just says, if my triangle is a 30 degree, 60 degree, 90 degree triangle, then the side opposite 30 degrees is 1, the side opposite 60 degrees is root 3, and the hypotenuse is always 2. Okay? Now this should make sense to you from geometry from last year, because you learned that a side opposite a larger angle must be larger than a side opposite a smaller angle. So that actually makes a lot of sense. That's not some surprise. Okay. Same here. These two are isosceles, so the sides must be the same. And then the opposite side is always root 2. Okay. And you can see that the relationship that we were hoping that you would get out of this inquiry activity here is still there. So how do I get from the shortest leg to the hypotenuse, multiply by 2, or from the short leg to the long leg, multiply by root 3, or from the in a 45, 90, from a leg to the hypotenuse, multiply by root 2, and vice versa, divide by root 2. Okay, so this is something you got to know, and then you can answer all of these questions. What is the sine of 30? It's 1 over 2, because you go 30 is here, 1 over 2, 30, that's opposite, that's hypotenuse, and you're done. Okay, so you can make up this whole table very, very quickly from those two triangles. If you want to memorize this, that's fine. I think a lot of students do memorize it. Okay, but that's not something I am going to make you do. Alright, so let's use this knowledge to solve to find the value of x for these next two triangles. And so we can do this two ways. One way is to use the understanding of the relationship between the sides and to solve it that way. So I can say, okay, the quick way is, I know that the hypotenuse in a 30, 60, 90 to get the shorter leg, I just divide by 2, so I know this is 4. Okay, and then to get from the shorter leg to the longer leg, I just multiply by root 3, so I know this is 4 root 3. So I already know x is 4 root 3. That's the answer, just by understanding the relationship between sides in a 30, 60, 90 triangle. Okay, the other way, so this would be way 1, which looks like no work, but it's just understanding the triangle's sides relationships to each other. The second way would be to do something like this and say, if I look at the triangle from the perspective of 30 degrees, I can say to find x, I can use the trigonometric ratio that is adjacent over hypotenuse. Okay, so I can go, which trigonometric ratio is adjacent over hypotenuse? That would be cosine of theta is adjacent over hypotenuse, and my theta in this case is 30 degrees, and adjacent is x, and hypotenuse is 8. Okay, and so then I can say, all right, but I know how to find cosine of 30 because I have a little triangle that I've memorized up here that I can use to find the cosine of 30. Now, if you've memorized the table, that's the cosine of 30. Okay, but you can just go here and say cosine of 30 is adjacent over hypotenuse, and that's root 3 over 2 is x over 8. All right, and then you can say, okay, so multiply both sides by 8, and then you just get 4 root 3 equals x. Same answer. Okay, same answer. One is just doing some math because you didn't necessarily understand the relationships between the sides. The other one is I know the relationship between the sides, I don't need to do all this. Okay, so if we do this with technique 1, how do I get from the hypotenuse to a leg? The answer is just to divide by root 2. So then I say x is 6 over root 2, but I can't leave it like that. We've got to rationalize, so I get 6 root 2 over 2. So x is 3 root 2. Okay? That's technique 1, just by understanding the relationship between the sides of the triangle. Or 2 would be to say, all right, if I look at the triangle from this angle, again, this is an adjacent side and this is the hypotenuse, so I'll do cosine again. Cosine, in this case, it would be 45 degrees equals x over 6. And then just multiply, well, wait, let me go here. And so you have this triangle in your memory. Yes, you do. Okay, and here's 45, and here's 45, and here's 90. So from 45 degrees, cosine of 45 is 1 over root 2. Okay, 1 over root 2 is x over 6. And then you multiply both sides by 6, so you get 6 over root 2 is x. And then if you rationalize, you end up with the same answer. Okay, same answer. So, 2 different ways you can think about it, all right? All right, and then I have to say that this has been something that surprised me last year was the students' difficulty with this type of question, solving a triangle, okay? Because solving a triangle has a specific meaning for us. Solving a triangle means find everything I don't know about the triangle, okay? So finding all unknown side lengths and angle measures is called solving a triangle. So what we did is we did this example together with students and we put it on a quiz and the students all went, what do you mean solve the triangle? So you need to know that. I'm not going to tell you that. That's a mathematical vocab, okay? Solve a triangle means find all unknown side lengths and angles, all right? And the second part that students had issues with was labeling a triangle. So they really didn't understand how to label a triangle. So I'm confused by this, but if you have a right triangle, or any triangle for that matter, okay, we label the triangle. Now, if it's a right triangle, we usually say let this be C because it's a hypotenuse, and we associate letter C with the hypotenuse from Pythagorean theorem. So we usually call in a right triangle, C is, no, this is capital letter C, is angle, is the right triangle, is the right angle, and then the side opposite that is lowercase c, and then A and B can go anywhere. So I put A here, then this is small letter a. And if I put angle B here, then this is small letter b. This A means the length of that side, this B means the length of that side, this C means the length of that side, and the capital letters all mean angles. You gotta know this. This is stuff you should have known since last year already, okay? And you could, like I said, you can choose to switch things around. You can put B here, then small b goes here. You could put A here, then small a goes here, but you must realize that small a means side length and big A means angle, okay? Measure of the angle. So there's that. That's how you label that. And what we're also going to do is, we could easily solve this triangle here and find all the information we want about it. Let me just erase some of my scribble here. Okay. Oh my goodness. Yeah, so we can easily solve this because we know that this angle is 60, and then we just find some sides and do Pythagorean theorem. Done. That's very quick, okay? This is similar, but here we're going to go beyond our known 30, 45, 60 degree triangle and go to a triangle that has a weird angle size that doesn't give us nice exact answers like we had here. They're still irrational, let's be honest, but I know exactly it's 3 root 2, okay? For these, we don't have triangles that I say they're all similar in this way, that the one side is root 2 times that one or something like that. We don't have stuff like that. So when it's not angles, when it's not basically one of these three angles, 45, 90, 60, or 30, we use our calculator. Okay, we use our calculator because the calculator's got an algorithm that it uses to do an approximation for us. Okay, and that's not something you have to worry about where that comes from. It used to be that people used tables, paper tables that someone had worked out, and they looked it up there. But we have the calculator to help us with this stuff. Okay, so we want to solve the right triangle, and now here comes the reason why I have my calculator on the screen is make sure your calculator is in degree mode. So if you go to mode, so please look at your calculator, go to mode, and then you go down to where it says radian and degree, switch it to degree mode. So go to degree, hit enter, make sure degree is highlighted, and then you can just quit out of here. Okay, so in the beginning, for most of what we're going to do in this chapter, honestly, we're going to be using a degree mode. Okay, we will work with radians, but we won't actually use our calculator in radian mode. Any case, so if I go here and I want to solve the triangle, basically what it means is find C, find A, and find angle B. All right, then I have solved the triangle. I found all the missing information. So the easiest thing to do first is measure of angle B. Measure of angle B, and that is because I know that this is 90, so these two together must be 90. So I can just say it's 90 degrees minus 28 degrees. And then you know that that's 62 degrees, okay? So there you go. Measure of angle B is 62 degrees. Please use your geometry notation for stuff like this. Don't just write B equals, because that's technically not what you should be doing. All right, and then if we go here, so we have angle B now is 62 degrees. What about side A and side C? So I can't use Pythagorean theorem because I'm missing two sides. So I need to at least use trigonometry to find one of them. So I'm going to go with the information it gave me, looking at the triangle from the perspective of the 28 degrees. This is opposite, and this would be adjacent, right? So how about I find side C first, maybe. How about that? Okay. So I do, I want to do a trigonometric ratio from the perspective of 28 degrees that does adjacent over hypotenuse. And that would be cosine. Cosine of theta is adjacent over hypotenuse. Okay. And so in this case, my cosine of 28 degrees would be 15 over C. And please, you can skip this. You don't need to do that. I'm just doing it because I'm assuming some of you are going to be rusty about this, okay? And then just multiply C both sides. And then just divide by cosine of 28 degrees. Okay, so that tells me that C would be, this would be approximation, 15 over cosine 28 degrees, which is, let's see what that would be. So now you just go on your calculator and you do 15 divided by, and I would put parentheses if I were you, but I think it'll work without that, cosine of 28 degrees, like that. Okay, and you get 16.99. I would round this to, everything for this chapter I would round to the hundredth. I think the textbook just called it 17, but let's be a little bit more accurate than that. Okay, so so we know that C is approximately 16.99, and now I can find, there's actually two ways you can find A. I can find A using a trigonometric ratio, or I can find A using Pythagorean theorem. If I were you, I would just stick with Pythagorean theorem because it's something you know very, very well, and you shouldn't make mistakes doing that. Okay, so I mean, if I use Pythagorean theorem to find that missing side A, I'm going to do C squared equals A squared plus B squared, and I'm going to say C is 16.99 squared equals 15 squared plus B squared. And if I don't really want to show you how to do all this, I think you understand how to do that. So if you do this, you get B would be approximately, because this side is approximately, so B will be approximately 7.98, I think is what you get. Okay. Did I do that correctly? No, sorry, not B, A. I filled this in absolutely incorrectly. Great. A is what I don't know. B I do know. B is 15. Okay. So A is what I'm getting. A is about 7.98. All right. And then you've solved the triangle. Solve the triangle means find all the missing information. I have all three sides and all three angles. I'm done. All right. So I'll let you work on letter B. Just in case you need some help there, I'm going to give you the answers, but you can pause the video here, try it, and see if you get the right answers. Okay. All right. So if you paused it, you can try that. There you go. All right, so then let's move on to this concept, and this gives students a lot of trouble for some reason, and that's angle of elevation and angle of depression. Okay, so for me, this is not that bad. I just really don't understand why people struggle with this so much. It's just vocab at this point. What is an angle of elevation and what is an angle of depression? Okay, so think of angle of elevation as in, if you stand on flat ground and you're just staring straight forward, and then you have to elevate your head or look up to see the top of the building. Okay, this thing here would be called the angle of elevation. All right, and then likewise, if you are standing at the top of the building, okay, and you're just looking straight this way, and then I want to look at, oh, you want to look at yourself. I want to look at someone down here. Then what I have to do is tilt my head down, okay, and look over here, all right? And then this would be called the angle of depression, right? The angle of depression. So, I mean, to me, that's very straightforward. It's just vocab. What do I call which angle, okay? So angle of elevation is this one, angle of depression is this one. And you can see if these two are parallel lines, then, or segments, I guess, then alternate interior angles tells me that these two are the same. Okay, those two are the same. So, any case, that's angle of elevation, angle of depression. I hope that makes sense to you. Let's For me, that makes a lot of sense, but some students struggle with that. Okay, and then let's do some questions based on that kind of an understanding. A parasailer is attached to a boat with a rope 300 feet long. Angle of elevation from the boat to the parasailer is 48 degrees. Okay, estimate the height. Okay, so h is what? So I suggest you draw a picture. I have some students draw beautiful pictures of this stuff. My pictures are all fairly ridiculous, but that's okay. So there's my boat, right, with a little prop there. Here's my boat driver, and there's the rope, and here's the parasailer, paraglider, something like that. Someone hanging behind the boat, seeing the sights. Fresh air in the face, beautiful, above the ocean usually, okay? And they say that the rope is 300 feet long, okay? And the angle of elevation, so if this is the horizon or the horizontal plane from the boat's height, then the angle of elevation is this. So in other words, if you're this guy and you're just looking this way, how far do you have to tilt your head up to see that guy, okay? And the answer is 48 degrees in this case. So that's the angle of elevation, okay? And the question that's being asked is, how high is this guy, all right? What is his height? Now, you may think of this and think this is ridiculous, but it's not really. I mean, if you are actually towing people, if it's on the ocean, fine, but if you're on some river or something, you know, and you're going under a bridge, it'd probably behoove you to know if you're driving at a certain speed and your rope is a certain length, how high is the guy going to be in the air, so you can avoid like going under a bridge and getting into trouble or something. Okay, so there are reasons why you want to know something like this. So let's find the height. Okay, so from the perspective, let me change the color. From the perspective of this angle, this would be the opposite side, and this would be the hypotenuse. And that's good because I can do that calculation and find the answer straight away. Because the only thing that's unknown is h. Okay, so if I'm looking at perspective of 48 degrees, this is opposite over hypotenuse. Okay, and that is sine of 48 degrees is opposite, which is the height, over hypotenuse, which is 300 feet. Okay, so the question is, how high is the person? So 300 feet times sine of 48 degrees would be h. Okay, so that means h is approximately, and on your calculator you can just type that in, 300 times sine of 48. Oh, that did not work. What did I type wrong? Sine of 48. Okay, enter. And so you get about 222.94 feet. All right. Just for interest's sake, just in case you're wondering, this doesn't have a unit. It's a ratio of two sides to each other. It doesn't have a unit. Okay. So if you think about this, if I'm in a triangle and I'm dividing, whatever, 20 feet by 35 feet, if I take the sine of that, I'm doing 20 feet over 35 feet. The feet cancel, so there's no unit here. Okay, it's just the sine of an angle is just a ratio. It's just a fraction. Okay. Any case, so there's that. So there's the height. You have the height figured out. Okay. For any trips you now take, you know if I drive at this speed and there's this angle of elevation with this long rope, then I can have my person be that high. Okay. All right. And then letter B, I'll let you try letter B. It's the same, basically the exact same thing. I'm not going to go over how to do letter B. Go look at, draw your own picture, challenge yourself, see if you get it, okay? Maybe I'll just give you the answer right here. It'll be good for you. Try it, and if you get stuck, go look at the completed note sheet. Right, that's the answer you should get. Okay, letter C, that's a nice problem to solve. Not very difficult, but still worthy. Okay, so what this is saying, let me extend this little thing out. Okay, so it says a tapered shaft, right? Tapered shaft. So taper means this. Okay, this would be a regular shaft. Tapered shaft means this. Okay, it gets thicker on one end. Okay, or the hole gets bigger, however you want to think about it. So this is not tapered, this is tapered. Okay, that's what tapered shaft means. And that's the picture they're trying to draw for us there. Tapered shaft has diameter of 5 centimeters here. Okay, so this is the 5 centimeter diameter right here. And at the small end, and it's 15 centimeters long. So I'm assuming what they're saying is this distance right here is 15 centimeters. Okay, it's not clear actually what they're saying. But that's what I'm assuming they're saying. Not this distance, but the other distance. Okay. And then it says the taper is 3 degrees. So this little angle here is 3 degrees. Find the diameter on the large end. Okay. So the diameter here is 5. They told me that. So find the diameter here. Okay. So what I need to know, and you can see that by the way that they drew the picture, that this means that, oh, that doesn't look right. Let me fix that. So if I do this, I have to connect up with that, right? So the way they drew the picture is this. So that what I can deduce from that is that this distance here is still 5 centimeters. Okay, but the shaft has been tapered, so I've added some thickness to this part right here. So there's a thicker wall here. Okay, and so the question is, what is D? D is the whole thing. D is the whole thing. Okay, so you can say, wait, there's 2 pieces, I don't know what they are, and that's this little piece right here and this little piece right here, and we can call that, let's say, X. Okay, and then this will be X as well. Okay, and so what I really want to say is I know that D must be 5 centimeters plus 2X plus those 2 little pieces. Okay, the problem is I have to find X, but now this, if you break it down to a smaller problem, okay, so I know how to find the length here. All I need now is X. So let's break that down into a smaller problem. And that is basically, let's take this triangle out of here. This makes a little triangle. Okay, makes a little triangle, a right triangle. And they're telling us that this is 3 degrees and this is 15 centimeters. Okay, so what I want to know is, what is this? That's my X. Okay, that's my X. So if I do that, I just say, well, what ratio is opposite? This is opposite and this is hypotenuse. Well, that's sine, right? So I just do sine of 3 degrees is X over 15 centimeters. And just multiply 15 centimeters both sides, then I get that. So X is about, this is approximation, and just go in there and enter that, 15 centimeters times sine of 3 degrees. And if you do that, you get about 0.79 centimeters. Okay, so my D is going to be approximately 5 centimeters plus 2 times 0.79 centimeters. And that would be what? If you do the math, I think you get 6.58 centimeters. Okay, 6.58 centimeters, something like that. Okay, so that's my diameter at the tapered end. All right, and then one last little problem-solving question. They get progressively more interesting as we go along. Let me remove this, and then we'll be done here. Okay, so example 7 says, passenger in an airplane sees 2 towns. So here's a town, here's a town. Directly to the left of the plane. What is the distance y between the towns? So here's the question. What is y? That's the question. Okay. Alright, so let me switch colors here. Explain the process you use to find the answer. So you should really communicate how you find your answer. You should be able to communicate how you find your answer. Okay. So we have two things going on here. So here's a little red angle. It's 15 degrees. Okay. And this would be called an angle of depression. Okay. So this is the angle of depression. It's 15 degrees. And basically, I can, with that information, I can make a triangle. Okay, with that information, I can make a triangle. And what I like to do is to use the idea of, this is obviously two parallel lines, so to use the idea of alternate interior angles to say that this is also 15 degrees. Okay. Now, some students do something different, and they make an upside down triangle here, and they say that this is 25,000 feet, and they said that that's 15 degrees, and then they know that the length here is the same as the length here, which is actually x plus y. You can do that. That's fine too. Okay, I'm not going to discourage that. I'm just saying I like to do it the other way. So I'm going to say in my little, let's say the red triangle here, let's call this the red triangle. Okay, if I'm looking at the triangle from there, I see that I can find, I'm trying to find y, so I need to do some kind of a calculation involving this side of the triangle and this side. So this would be opposite, and this would be opposite, and this would be adjacent from perspective of the red triangle. Okay, and so I'm going to do that. So let me write something like that. Opposite over adjacent, that's tangent. And I'm going from 15 degrees, that's my perspective I'm looking from here. Tangent of 15 degrees is 25,000 over, and then this whole distance here, that whole side of the triangle is x plus y. Okay, and then you can just keep going. This, and solve it as far as you can get to get y by itself, because we're trying to find y. So x plus y, if I just divide this out, I get x plus y is 25,000 over tangent of 15 degrees, and then just take the x to the other side. Okay, and pretty quickly that's what you have. So I already have y. I know the answer. All I need to do is find the missing thing, which is x. Okay, which is x. So now you do a similar thing. So you go, okay, my whole question in the beginning was y. I did something with the 15-degree angle and that kind of triangle you can form. So let me change to the blue one. So then they told me that this angle of depression is 25 degrees. Okay. That means that for me to see this town, I need to look down, and that down-looking angle that I'm taking is 25 degrees. But again, using the concept of alternate interior angles, this is 25 degrees. Okay. So now I can say, looking from the perspective of this angle, if I want to find x, again I do, tangent, right? Opposite over adjacent, right? That'll give me what I'm looking for. So if I do tangent of 25 degrees, that's 25,000 over x. All right? And then all I have to do is solve that question. So now I get x times tangent 25 degrees is 25,000, and then divide out the tangent of 25 degrees. So x is about that. Okay, 25,000 over tangent 25, which, if you do the approximation, let's do it. 25,000 over tangent of 25 degrees. Okay, so you get some massive number. 53,612 0.67 feet. All right, so there's x. So now all I have to do is just plug that in here for x, and I've got my answer. So let's substitute this in, y, and it will be approximation at this point. And now I have to plug that in too, so same calculation, except it's 25,000 tan 15 degrees. Okay, so it's a lot bigger, 93,301.27 feet minus 53,612.67 feet. And that would be, if I take that minus this, you get 39,688 let's say 60. Okay, if I round to the hundredth, let's say 60 feet. Right, something like that. All right, guys. So I hope that that was informative for you. Please, you must be able to do things like example 7 and example 6 ABC. You must be able to do some problem solving. I mean, problem solving is the real reason we learn any mathematics. Okay. All right, guys. Thank you.